So good morning everyone. My name is Arslan and you are watching Proper Tech Tutorial. So welcome back to the series of learning Siemens NX from beginner to pro. And today we'll be starting part 17, that is the geometric constraints that are available in Siemens NX. So without any further ado, let's start. And if you like our series and if you want such content, do hit the subscribe button and share our videos. And let us have a look on the syllabus that will be covered today, that is geometric constraints. So first of all, what is a geometric constraint? So geometric constraint is something that allows the user, the designer, to constrain their sketch, their model in a geometrical fashion. For example, let us create a new file. We will name it as part 17 training. And if you have not watched our previous videos, the link is in the description for the playlist. You can watch it from there. Okay, so for example, I have a rectangle that is over here, and I want to constrain it in such a manner that the rectangle becomes a square. So the basic operation that can be done is that you have to select the side, you have to select the adjacent side, and after these two sides are selected, they will be highlighted, and you can select the option of make equal, and you will see that an equal constraint has been applied on the rectangle. Similarly, for example, I have a circle, I have another circle, and I want it to be concentric. For example, I want both the circles to originate from the same center. So what can I do is that I can just click on, I will check this point, I will check this point, and I will click on coincident. Okay, this is also a method of doing geometric constraints. Another way of doing, or another thing that is available is that, for example, I have a line this, I have another line that is this, I have one line that is this, I have one line that is this. So I want to make a rectangle out of these four lines. So what will I do? I will just select this line, I will select this line, I will make it equal, I will make it parallel. Okay, so for parallel, it will give a dialog box, and I will select the motion and the stationary curve. So the motion curve is the curve which, when selected, will get applied the same constraint or same thing as that of the stationary curve. For example, if I select this as the motion curve and I select this as the stationary curve, then it will get translated, or it will get modified the same as the stationary curve. You get my point? Also, I can make multiple objects constrained to one stationary object. For example, I want this line, and this line. So you can see that it automatically gets into the stationary curve option. So I do not want that. So what I will do is that I will refresh it. I will click the first line, and then again I will click the motion curve. I will click the second line. I will click the third line. After that, in the stationary curve option, I will click on this line, and you will see that the preview is generated, that all the three lines have become parallel in the same orientation as that of this line, which is selected as the stationary curve. Okay. Another thing that can be done is that, for example, as I told you that I want to create a rectangle out of this. I will take this line and I will take this line and I will make it parallel. After that, I will take this line and I will take this line, I will make it parallel. After that, what I will do is that I will take this line, the stationary curve, I will make it horizontal, and I will take this line and I will make it vertical. After that, I will take this line and make it equal. And now the last thing comes, joining all the four lines. So this point and this point must be coincident. This point and this point must be coincident. So while selecting points, either it be end point or points of a contour or end points or any start point, you have to just hover your cursor on that feature, on that curve, or on that quadrilateral, or on that arc, and it will allow you to select the points related to that. For example, if I want to select the center or the origin or the arc center of the circle, I just have to hover my cursor for 1 second or 2 seconds on the arc, and it will display the arc center automatically, and I will be able to select it. Similarly, I have joined these three lines. Now the thing only remains that I need to join this line and this line. I will make it coincident, and you can see if I try to move this, it will follow the relations such as the parallel and the equal relation. And if I try to move this line, it will follow the parallel and the equal relation. Furthermore, if I want to make a square out of it, I will select these two adjacent lines and make it equal. So now if I try to move it, you will see that it will move in such a fashion. After that, I can also apply a geometric constraint that will be discussed in the next video, but just for clarity, I will show you how to apply a geometric constraint, and that has been done. So now if I try to move the square, you will see that the square follows the geometric and the dimensional constraint and is moving as per my cursor's input. Now the second option is that if I want to make this rectangle to be to have the center as this, you see this origin of the sketch, the 0 0 0 of the sketch. What can I do is that I will make a circle. I will make a circle like this. After that, what I will do is that I will make the radius of the circle. You can see that I will make the radius of the circle to be like it is 44.8. So I want it to be 143 divided by 2, and it will give me a circle like this, and I will make this 143 exactly, no points. After that, what I will do is that I will make this point arc center, okay, and then I will select this line and I will make it in the midpoint. So for that, what I will do, I will click on the make midpoint align, and you will see that the circle has been created in midpoint of this edge. Furthermore, if I want the midpoint to be aligned with this edge also, I will select this edge and I will make this midpoint aligned. Now you can see that if I try to move the square, it will move along with the circle in the center. Now what I have to do is that I will convert it into reference, and then I will select the arc center of this circle. I will select the origin and I will make it coincident. So this will make our square in the center or originating from the center of the origin. Another method of doing such thing is that we can just take the rectangle and the option of originating from center. We have discussed that in our previous videos, that is in the part 12. And I will just make a rectangle originating from the center. And now my rectangle has been created. I want it to be a square. I will make it equal. I want the side to be 143. I will make it 143. Okay. So now this square has been created with a 143 side, and it is like restricted for with the origin center. Now if I try to move it, you can see that I am unable to move it. So if I just delete these two sketches, and you will see my sketch is fully defined. So this is the power, or this is the advantage, or this is the feature of using a constraint. So what is a constraint? I hope it is now clear to you. A constraint is anything that allows the user, the designer, the modeler to restrict the dimensions or geometry of that feature or the sketch. That is a constraint. That is why there are two types of constraints, geometry constraint and the dimensional constraints. Now we will come to constraint types. How many types of constraints are there? What are geometric relations, automatic geometric relations, and so on. So how many types of constraints are there? We will come to that. So for that, I will just finish this and come out of the sketch environment. I will go into the utilities, customer defaults, and in the sketch tab, and after that I am the session settings. So in that you can see that you will be able to let me get to that point. Yes, I will go in the inferred constraints and dimensions. You can see the types of constraints that are available, the geometric constraints that are available in the Siemens NX. So first is horizontal, vertical, horizontal alignment, vertical alignment, tangent, parallel, perpendicular, collinear, concentric, equal length, equal radius, coincident, midpoint, and point on curve. Okay, so these are the constraints that are available in the NX, and you can tick mark them or uncheck them if you want them to be automatically placed or not. So now coming back to the sketch environment, I will just show you each constraint one by one. So I have shown you the horizontal. For example, this is a line, and this is a line, and let us create another thing like let us create one more line. After that, let us create a circle. After that, let us create okay. Let us create two more lines. Okay, and let us create a another quadrilateral. So let us create a polygon with the side 6, specify point. Okay, so let us specify the point to be somewhat like this, and this rectangle will be made. And I can do what? I can just refresh it. I can put the radius like I want it to be 100 and 0. I can just click on lock, and I will be able to place the quadrilateral in a fixed orientation with a fixed dimension. Now we will come to all the rest constraints one by one. So first was the horizontal. So I want to make this line horizontal. So as soon as I click on this line, you will see that the options in the constraint, dimensional constraints, which can be applied are automatically highlighted, and others are unhighlighted, or they are subsided by the NX automatically. So I will just click on the horizontal, and you will see that the line becomes horizontal. So if you do not have this version of NX, the latest version of NX, you can just check our channel. The link will be in the description, or you can just search for the how to install Siemens NX, and you will find it in our page, Proper Tech Tutorial, and you can install our Siemens NX. Like every step by step is given, and a link is also given in part by part because of some YouTube copyright issues. So you can just copy it part by part and paste it in the address bar, and then you will be good to go, and you can download the setup, and everything will be in your hands, and you can install it accordingly. Now coming back to the constraint topic, second thing is that if I want to make this line, for example, and this line to be just, I want to make it like collinear, or I want to make it perpendicular, I will just click on this, and you see that these two lines have become perpendicular to each other. For example, if you want to measure it, I will just show you by measuring it. So I will click this, and you can see the angle is 90 degrees. So this means that they are now perpendicular. After that, what I want to do is that I want to make this line and this line coincident or intersecting. I will hover my cursor on this line, and I will hover my cursor on this line, and this will give me the option of selecting. So sometimes when the NX is confused as to which point you are actually trying to select, and you hover your cursor for 2 seconds and then click on it, the drop down menu or a pop-up dialog box will open on the top right corner, and you will be able to select what you are trying to select. So I will select this endpoint and I will make it coincident. Okay, as far like I think that it is clear. Secondly, if I want to make this line at the midpoint of this line, what I will do is that I will just take this line and I will make it, I will take this point and I will select this line and I will make it midpoint. And you can see that it has extended till the midpoint of this line. But I want this line to be like or like with the same dimension. So what I will do is that I will just do Control Z. I will give it a rapid dimension. For example, let us see that. Let us do a rapid dimension of this. It is 97. No matter, we will give it to be 100. So rapid dimension we do not want in this manner. We want it to be in this, the exact length. And I will double click on it. I will type 100 and I will press enter. And you will see that the dimension has changed to 100. After that, I will click on this point. After hovering it for 2 seconds, I will get the option of selecting the line or this point. And then after that, I will click on this line and I will click on midpoint, and you will see that the line with the same dimension of 100 gets translated in the same orientation, like the whatever inclination or whatever the degree it was, as so as the starting points comes at the midpoint of that point of that line. Okay, now I want to make this line to be vertical. I will make it like this. Now I want to make this line to be like I want the point of this line to be okay, the midpoint relation is there and the line is there. Okay, so now I want to select this point. Okay, and I want to make it coinciding. I will select this line and I will click on make coincident, and you will see that following the midpoint relation, following the dimensional constraint, following the vertical constraint, the line has made itself so as to coincide its start point with the line 13 of the sketch. Now I want to close this curve with these two lines. So what I will do is that I will take this line, I will take this line, I will make it equal first of all, I will make it parallel. The motion curve will be this one, the stationary curve will be this one, and after that I will click on OK. After that I will select the start point, and then I will select this point of line 13 and I will click on coincident, and it has placed itself accordingly. After that, I want to make the final edge of the rectangle to be placed over here. What I will do, I will click on this line, I will click on this line, I will make it parallel. Okay, after that, I will make it equal. You can also make it equal by first, or you can make it equal later on. So motion curve will be this one, stationary curve will be this one, and you will click on OK, and it has been made equal. After that, what you will do is that you will click on the start point, you will click on the end point, you will make it coincident. So now this curve has been closed, and you can see that this line has somewhat like exceeding the curve. So what you can do, there are two options. Either you can trim it or you can use the geometrical constraints. So we'll be using the geometrical constraints. We'll click on it, and we'll click on make equal, and you see that all the three lines are equal to each other, and these two lines are equal to each other. Now I want to make this line as a reference. I will just click on it and I will wait for a second, and you will see a pop-up dialog will show up, and this will make you convert from reference or make you convert out of reference. Okay, so now it is converted to reference. After that, what you can do is that like you can use this reference as a line in construction, etc. For example, I want to mirror, for example, this curve, and the center line should be this, and this will mirror that. Okay. Now, these were some of the geometrical constraints that were used. Now coming to other geometrical constraints, and just I will open the utility section again so that you can see that what more geometrical constraints are remaining. So we have discussed horizontal, vertical, tangent. No, tangent has not been discussed. Parallel, perpendicular has been discussed. Collinear, we'll discuss. Concentric, we have discussed. Equal length, equal radius has been discussed. Okay, equal radius I will show you. And midpoint has been discussed. Point on curve, that will come after that. Point on curve is something when you use one sketch with another or sketch with along with a feature and coincident. Okay, so only few are remaining. We'll come to that and we'll cover it in just a few moments. So now I want this circle to be inscribed inside this rectangle. So what I will do is that I will make this circle to be aligned with the midpoint of this diagonal. So what I will do is that I will just create some construction lines. I will take this point, I will take this point, and then I will take this point, and then I will take this point. After that, I will select these 2 points. I will select this line and I will select this line, and then I will just do a right click and click on convert to reference. After that, you can see that this point has like been generated. So what I will do is that I will take this circle, I will select this arc center, and after that I will hover my cursor on this line or on this line, and just I will hover it for 1 or 2 seconds, and you will see that options have been generated, and I will click on line 26 and you will see that the midpoint has been created. So for that, only one diagonal is also sufficient, this is also sufficient, or this is also sufficient, but just to make you understand, I am doing this, that the midpoint of the of the of of the 2 diagonals and the midpoint of the line which is starting from the opposite edge and ending at the other opposite edge of the rectangle, that midpoint always coincides. So midpoint of this line, midpoint of this line, and midpoint of this line always coincide with each other. Now coming back to the topic, we'll select the arc center, we will select the midpoint, and just we will translate this circle to this point. Okay, doing it again for you. Arc center, we will select this line and we will select the make midpoint aligned, or what you can do is that okay, I'll just do a Control Z and this line and the arc center and make midpoint aligned, and you will see the midpoint is trying to align itself, but somewhat something is not following its course. So what we'll do, we'll select the line, we'll select the point, and we'll select the arc center, we'll select the point, and we'll make it coincide, and you can see that it has coincided as per our relation. So we have not given any dimensional constraint as of now. So sometimes when you try to give any constraint geometrical, if there are no dimensional constraints given, then the dimension might get modified or changed by the nx. So that is something which needs to be taken care of. Okay, so you need to understand that. Also, this dimension has been given, so if I try to move in this direction, then this 100 will always be abiding by itself, but if I try to move in this direction, it will not be abided by any dimensional constraint, and it will move freely only on the geometric constraint, that the midpoint is always followed. The midpoint constraint is always followed. This reference line is always followed. If I try to move this circle, it will also follow the same. If I try to extend it, it will be extended because no dimension has been given as of now. Now, coming back to making it, we have inscribed it. Now we will make it tangent to one of the sides. Now we have given it 100. We will give this direction also. Let us say it is 200. So after we, like, see, there are various methods of dimensioning the object. The first method is that I just click on the line and the dimension automatically pops up. So if I want to give it a dimensional constraint, I will double click on it and I will input the value using the keyboard and press enter, and you will see that the dimensional constraint has been given to it. Another method is that I will use the rapid dimensioning tool and it will give me the option of dimensioning it. Another method is that I will take the linear dimension and try to give the dimension in this manner. Okay, so there are various methods. Let's not dive into that. We will discuss that later on. Now we have to make this circle tangent to this line. Let's say line 13. So we'll just click on the two, this arc, not the arc center, the arc and this edge. And after that, we will click on the make tangent relation. And you will see that if we try to move this, it will be moving while abiding the tangent relation. Let us delete this relation, the dimensional constraint, and try to move it. So what you will see is that if you try to okay, sorry, if I try to change the, if I try to move this rectangle, you will see that the tangent relation will be followed always. And since there are no dimensions given, the dimension will take its size accordingly. Okay, so this is the power of tangent relation. Now, if I want to make this circle bigger, let's say I want to make this circle much bigger. So what I will do is that I will just click on it. After that, I will have a point on the perimeter, and that point is over here. I will click on it and I will increase it, and you will see that the dimension is changing for both the rectangle or the opposite edges and the circle. And you can, whatever you, for example, I like this, so I will just keep on like this, and my sketch is edited. Now coming to the next topic. So constraint types have been discussed: the coincident, collinear, horizontal, vertical, tangent, parallel, perpendicular, equal, and now comes the make symmetry. So I hope that these things are now clear. What is constraint, constraint types, and the last constraint type, that is symmetry, will now be discussed. So I made a polygon. I think it is deleted. So I'll just make a polygon and then I will make a line. So after that, what you need to understand is that anything can be made in symmetry with another thing only if that is parallel with each other. So for example, if you want this polygon to be in symmetry of some sort with the reference of this line, it needs to be parallel with either of the edge. So first what I will do, I will select either of the edge, I will select this line and I will make it parallel. Okay, so now if you see that this polygon, if I try to move it, the line is also moving, also the dimensions are not defined. No problem, we'll just dive into symmetry. So first we'll click on the symmetry tool, and after that I will select the three options that are given to me. So first is the motion curve, so thing which can be moved. After that is the stationary curve, or the point that cannot be moved. So something like that can be like this line, and then there will be a symmetry line. So you see that the curves only move. There is a dialog box showing an error that this stationary curve must be moved in order to make the symmetry to happen. Okay, so this thing makes us understand that the symmetry line should be somewhat inside the, should be constructed inside the polygon or inside the shape or inside the sketch. That is, it should be not exactly in the between, but it should be somewhat between the start and the end. So what we'll do is that we'll translate this line to be over here. Okay. So after that, we'll again open the symmetry tab, make symmetry, and we'll click on the motion curve. I selected the point. We'll click on the motion curve. We'll click on the stationary curve, and then we'll click on the symmetry line. And you will see that this symmetry has been obtained perfectly. Okay, this is one result. Another result, if obtained while if another result can be obtained by specifying the dimension of the polygon. So what we'll do is that we'll just specify the dimension. It is 133. Let us keep it at that, and we'll click on the outside, and you will see that now the polygon has been restricted with the dimension. The angle orientation is not restricted, but the dimension has been restricted. Okay. Now I will click on the symmetry tab again, select the motion curve, the stationary curve, and the symmetry, and you will see that the symmetry line moves as per the motion and the stationary curve. So there are two types of results that can be obtained while using the symmetry feature. I hope you understand that. First thing is that the line of symmetry should be in parallel with the motion curve. Otherwise, it will not be able to generate a proper desired result. You can hit and try as per your as per your understanding, and you will get various results which might be useful in your construction. So construction types have been discussed. Constraints types have been discussed. So what are geometric relations are also discussed. Geometric relations are something that constrains the sketch, that constrains the curves only purely on the basis of geometrical concepts such as coincident, collinear, horizontal, parallel, without specifying any dimensional constraints. Okay, like I do not want to specify this dimensional constraint. I just want to make a square. As you see, we made a square over here. So if I delete this dimensional constraint, you see that it will still be a square. Even if I make it no matter how small or no matter how big, it will still be a square, abiding by all the geometric constraints. Next is automatic geometric relations. Now, for example, if you are trying to make a sketch and you want that some things should be automatically placed in the sketch, like for example, I am trying to make a line that is collinear with this line. So it will automatically create a trace line, and it will create a constraint like that. For example, I want to make a line that is in midpoint and horizontal to the line previously created, then it will automatically create a trace line, or it will automatically snap the midpoint. If I want to make it like tangent to this circle, you see that a tangent relation is getting displayed when I hover over the arc. For example, I want this to coincide with the line 10, the end point of the line 10. It will show us the option of snapping at the end point. If I want it to coincide with the midpoint, it will show us the option of snapping to the midpoint. If I want it to be like at the center, if I want it to be parallel with this line, you will see that if I try to make it like somewhat parallel to the line, it will automatically snap to the same orientation as that of the polygon's edge. I should zoom it for you, and you can see that it is automatically getting snapped. Also, if I want to make the line to be like somewhat in this manner, that it should be exactly above this point, and you will see that a trace line is getting generated. So these are some of the automatic geometric relations that can be made automatically by Siemens NX. If I try to make a circle, and you see that it will automatically make it concentric with this circle by selecting the arc center. If I want to make it co-radial, you will see that that circle will get tangent to this previously made circle. If I want to make like a circle that is tangent on the outside, you will see that a tangent relation is getting displayed. So various types of geometric relations will get automatically will get automatically considered by the Siemens NX intelligence based on your preferences, which can be set by going into the File tab, drop down menu, Utilities, and then the customer defaults. And in that you will go into the sketch environment. In that you will go into the session settings, and you will see that you have the option of applying automatic, like create dimensions or change view orientation, etc., etc., create dimensions for typed values, etc. Okay, then if you get to the inferred constraints tab, you will see that you have the following options which have been selected to be considered by the Siemens NX. If I want to create alignment constraints, I will tick mark. If I do not want, I will uncheck that. Similarly, if I want to have snapping options, like I want something to be made parallel to something, then parallel, as you saw that the line was having a trace line that was parallel to the edge of the polygon and becoming perpendicular, becoming tangent, etc. So these things can be checked or unchecked based upon your preferences in this pop-up dialog box. Now coming to applying shortcuts to apply geometric relations, is that by using this automatic geometric relations that allows the user to create while making a sketch only. Now quick pick tool and snap pointer has also been discussed. It is just below the input constraints. I just showed you that. I will show it to you again. See, this is the sketch, input constraints over here, curve snap options over here, relation finder over here, and intent rules over here. So all the things are available in these four sections of sketch in the utilities section. After that is the deleting of relations. So how do we delete a relation? So the most easiest way of deleting a relation is that, for example, I want to delete this midpoint relation. I will just hover my cursor on this line, and you will see that the line and arc are getting displayed, but the midpoint relation has been applied on this. So I will just click on it, and you will see I will go like around it, and these three dots will display. I will click on it, and you will see that on the top right corner a dialog box opens up, a pop-up box opens up, and a midpoint relation is also there for selection. I will select that, and I will get the option of deleting. I will delete that. Another way of deleting a relation is that I just press Ctrl Z, is that you will get the relation, and just if you take your cursor onto that relation, it will get highlighted. So if I just take my cursor and click on the relation, it will get highlighted, and I will just press my delete button on the keyboard and it will get deleted. Understand that? I will just click on this relation, I will press the delete, and it will get deleted. Okay, so now these are various methods of deleting. Another method of deleting is that I right click it and I will get the delete option. So there are various methods. It depends upon your preference and your feasibility, which is the method you most like to use. So if you select any of the two things, any of the thing or any of one thing, the geometrical relation that can be applied will automatically get highlighted. For example, I select this line, you see that the geometrical relation that can be applied is only horizontal and vertical. If I select this circle also, more geometric relation will get highlighted. If I do not select this circle, rather I select this line and I select this line, you will see other relations getting highlighted as per the scenario. So applying geometric relation, dimensional relations in Siemens NX is very easy, and Siemens NX will be covered in a total of 37 lectures, because we will be delivering every topic, every point in as much clarity as possible. So keep following this series, and soon we'll be starting SolidWorks, how to master SolidWorks from beginner to pro. And after that, we'll be showcasing some of the models or some of the sketches, how to make that. We'll search for some things on the net and we'll make a video as to how to make those things. And it will be beneficial for those who are working professionals and mechanical in the design, maintenance, installation departments, or who are enrolled currently in the BTech degree. So this is all for today. And after that, in the part 18, we'll be dealing with the dimensional constraints. So whatever you have learned till now, till part 17, I will suggest you to please practice that, as practice makes the man perfect. And if you like our series, do hit the subscribe button. And if you find it useful, you can share it with your friends. And the next time we meet, goodbye.